Hello and welcome everyone. In this video, we are going to discuss about Signum function. Signum function is a special type of function which will be defined by f of x equal to signum of x. It has three possible outcomes, 1, 0 or -1. For any negative real number will be taken as an input, positive real number. If the input x is any positive number, the outcome will be 1. If the input is 0, the outcome will be 0. But as an input, if we take any negative real number, the output will be -1. So signum x has three possible outcomes, 1, -1, and 0. Remember, absolute value of x is the same as, it is a function. When it comes out, it has to be plus or minus x. When x greater than 0, the outcome will be just x as it is. If x is less than 0, the outcome will be -x when x is greater or equal to 0. If it is 0, it will be just 0, positive numbers also directly will be extracted. But if negative numbers are inserted in absolute value, the outcome necessarily has to be positive. For that matter, we have to put negative here in front. So absolute value function, it has its own special property. The same manner, signum function also, they do have it has its own special property. So for example, if the function is signum x, for example, signum of -1 is -1. Signum of -5, again -1. Signum of -100, again it's -1. Whatever the number here taken, if the number is negative, the outcome will be -1. Signum of, let's take 4, it's 1. Signum of 3.5, still 1. Signum of 1/2, still 1. Any positive real number taken as an input, the output will be always just 1. So remember the restriction here. For any negative input, the output will be -1. Any positive input, the output will be 1. Those are range. So we can state the domain and the range of signum function. The domain, it will be the set of real number. We can take as an input any real number, either 0 or positives or negatives. But the range, it is restricted. Just -1, 1, and 0. There is no other numbers. The output means the range. The inputs are the domain. So as an input, we can take any number, but the output will be either of the three. So the domain and the range of signum functions are this, what you see here on the screen. The domain real number, but the range -1, 1, and 0. How does the graph of signum function looks? Let us see. The graph of signum function looks like what you see here on the screen. Here on the screen, for any input, like if you take 1, the outcome will be 1. 2 in the x, the output will be 1. 3, just 1. 4, 1. 4, 5, 1. So always the graph is a horizontal line, y is equal to 1. For x greater than 0, for any number x greater than 0. But it makes whole, as you see here. It makes whole. That means the 1 at 0, 1, this is not part of the graph. But always for positive real number, the graph will be constant. It's y is equal to 1. But at 0, it is 0. As you see, the whole will be closed at this point. Less than 0, if you take any number, -1, -2, -3, -4, any negative numbers, the outcome will be just -1. So the red line will be a horizontal line. Again, this line is y is equal to -1. So there are, we can say it is a piecewise defined function, because three functions, it looks like the graph of three functions, but it represents just one function, that is signum x. So the domain, as I said before, it will be the set of real number, but the range will be just 1, -1, and 0. Let us see some examples on this. For example, here it says sketch the graph of f of x is equal to x plus signum x. This is the same as x plus 1 or x minus 1. we do have three possible outcomes here. What are they? The first one, as I said here, it's x plus 1 when x greater than 0. If positive number is taken, the signum x will be 1. This x, it comes as it is. The second outcome is just x when x is equal to 0. If x is 0, the signum value or the signum function will be just 0, so that x plus 0 will be x. The last one, x minus 1, when x less than 0. So how does the graph looks? Just rough sketch. X plus 1, it is a line passing through the point when you substitute 0 in place of x, just 1. Here it is. Then it's a line, straight line. But the 0 point, this point is not part of the graph. So we have to put a hole here. The upper one. The second one, it is y is equal to x. We have three functions here. Y is equal to x plus 1, y is equal to x, and y is equal to x minus 1. So y is equal to x plus 1, it is a line, straight line, slanted to the right. Where does it cross the y-axis? When you insert 0 in place of x, you will get 0 plus 1, just 1. So it will be a line. But we are using it for x greater than 0, so I will ignore the other wing, above 0 only. The second one, y is equal to x, it is only just for x is equal to 0. Y is equal to x is, again, it is a line passing through the origin, but it works only for origin part. So we can represent by red line. Here it is. The third one, it is y is equal to x minus 1. If you insert 0 in place of x, if you substitute 0, 0 minus 1 will be negative 1. So again, it is a line, but for x less than 0. We are going to consider the left-hand side of this line. So this graph represents the graph of the function f of x is equal to x plus signum x. So remember, the division part happened because of the signum x. Signum x, it will be either 1 or plus 0 or 1. It depends on the input. If the input positive, it will be plus 1. If the input is 0, it will be just 0, so that it will be y equal to x only remain. If the input is negative, we can take negative 1 as output. So this is the graph of the function. What is the domain? The domain is a set of real numbers. What about the range? The range is, it is a set of real number, but without this interval. We have to exclude this interval from here to here. This interval is from 1 to 1. Union the 0. The 0 is part of the range because, as you see, it is closed already. So it is all real number, but without which interval? The interval from 1 to negative 1. From negative 1 to 1. And union again is a 0 because from negative 1, 1, there is a number 0. That 0 is part of our graph. The 0, as you see, it's closed here. But the other here from negative 1, 1, it's not part of our graph. So when we are talking about the range, we are talking about the y-axis. So which part of the y-axis is part of the graph, like it is included? Below negative 1, everything works. Above 1 also everything, because the graph continues both sides, up and down. But middle, from 1 to negative 1, just it's empty space, except 0. The 0 is our part of the graph, so that we will include. Let us see some other example. The second example here, it says f of x equal to x signum x. Again, we can categorize here, it is x, 0 or negative x. When x greater than 0, when x is equal to 0, and when x less than 0. So we do have three graphs. Y is equal to x, y is equal to 0, and y is equal to negative x. Remember, y is equal to x is a line passing through origin and slant to the right. But I have to take this part, just a line. And don't forget that. It will make hole here. The second one, y is equal to 0. When x is 0, y 0 means the hole will be closed right now. At 0, 0, the hole will be closed. And y equal to negative x, it is a line slanted to the left. From here to here, again, it will continue. But I will consider only for x less than 0 means I will ignore this part. So the graph remains up right and up left. So this graph looks like the graph of absolute value of x. So we can say x signum x and absolute value of x. The graph is similar. What is the domain? The domain is a sort of real number. We can take any number. What about the range? the range will be y greater or equal to 0, because the graph is completely above the y-axis, the x-axis. So that the range will be y greater or equal to 0. So this is a graph of y is equal to x, signum x. One last example. Here again, we have a function f of x is equal to x squared signum x. This is the same as x squared 0 or negative x squared. We have three functions again, for x greater than 0, for x is equal to 0, and for x less than 0. Now, y is equal to x squared. It is an upward parabola. Don't forget that. And y equal to negative x squared, it is a downward parabola. Both of them, the vertex will be origin. So that how does the graph looks? Let us see. The first part, as I said before, it will be an upward parabola. It will be bent at origin. This is a graph of y is equal to x squared. But this y is equal to x squared works for x greater than 0, means I have to ignore the left wing, this part, and it's going to make hole here. Again, when x is equal to 0, the y is equal to 0 already. That means that hole is going to be closed here now. The second one, the third one, it is y is equal to negative x squared. Again, this graph will be a downward parabola. It's a downward parabola. But it works only for x less than 0, means I have to rub the right wing. So the graph will be upright and down left passing through the origin. This is a graph of odd function. So x squared signum x, it is the same as x cube graph. The domain will be the set of real numbers this time, and the range also will be the set of real numbers, because the graph continues up and down both sides. So this is x-axis, this one is the y-axis. You can take as an example and practice with the function f of x is equal to x cubed signum x. How does the graph looks? But for me, this is going to be the end of my video. Don't forget what means signum x. Signum function is a function which will be written in the form signum x is equal to 1, 0, or negative 1. It depends on the input. This is our today's lesson. Thank you for watching.